Hi, everyone. Welcome back to Talk Math with your friends. Our speakers today are Dr. Lucy Rycroft-Smith and Darren Macey of the University of Cambridge. Dr. Rycroft-Smith and Dr. Macey are both researchers, writers, and designers in math education. Dr. Macey has written a book titled Teaching Statistics with Cambridge University Press, and Dr. Rycroft-Smith is a co-editor of Flip the System UK, a teacher's manifesto, which Dr. Macey has also contributed to, and she is the author of The Equal Classroom, Life-Changing Thinking About Gender. Both of these are through Routledge, and please join me in welcoming Drs. Rycroft-Smith and Macey.
Thank you so much. I'm so sorry I'm laughing. It was an excellent introduction. We are not yet doctors, which is why we're laughing. We are hoping to be soon, and we're both very excited about that. Very excited about that, more than anyone will ever know. Okay, so I'm going to go ahead and share some slides, but hello, you're so welcome, and we're so delighted we have people here, and we're so delighted to be able to talk to you as the two of us, because we spend all day talking about this kind of stuff just to each other and occasionally other people, and it's we're sending us giddy with excitement to be able to talk to this amount of people. So please do put some comments on the chat, and exactly as these guys have said, please do just comment and ask questions as we go as well. We would love to have your input. Okay, all right, so can I get a little thumbs up if you can see what I'm sharing? Excellent, perfect. So please feel free to tweet if you're a tweeter, and if you're not, feel free to not. As we go through this interestingly titled talk, and as I said on Twitter this week, this was not the only title, there were various rejected ones, but vaguely situated in the realm of pie charts. Okay. So a little introduction. I'll introduce Darren and he can introduce me, which is what I've done with this slide. So thank you for the very useful introduction situating our work within maths education, research, designing and writing. So I've put there that Darren is annoyingly asking the purpose of everything, and that's true. That's what he does all day long. And he is somebody who likes to get to the bottom of exactly why we are doing something and why anything exists, which is very irritating but also very useful. And so Darren, do you want to talk a bit about what I do?
Yeah, I mean, you've put me on the spot slightly now. I hadn't thought about it in advance, and I've only got rude things going around my head.
Go for it.
So in very much the same vein, when I'm asking what the purpose of something is and why we're doing it, Lucy's normally drawing a picture to explain why, or at least try and make it simpler and more easy for everyone else to understand, and also more beautiful to understand.
Correct.
I think that's probably the easiest or the strongest description is to say that Lucy will look for the beautiful picture of anything that she can possibly do related to maths and breathing and being alive in general, and sharing it with us.
Thank you.
And so all of the slide work today is hers.
Yeah, so we work at the University of Cambridge. We're also studying there. We work at an organisation called Cambridge Maths, which we will allude to briefly today, but we won't go into detail because it's a very massively ambitious, hugely complicated, hugely interesting project, which would take more than an hour to talk about. But we design, we write, we research about maths education. We have our own areas, but we also talk sort of across and about all areas of maths from age 3 up to age 19 internationally. Okay, and so we're really excited to be talking today because the concept, I think, is very familiar to us. We spend all day long, every day, doing exactly this, talking maths with your friends. And I've put some optional plurals there, partly because this is international and partly because it's debatable whether we have more than one friend. Okay. So I realised that when talking to this audience, it might not be completely clear what maths education design actually is. Because those three things separately might mean particular things, but mash them all together and they've got a very specific meaning. So I'm going to hand over to Darren just to sort of explain what we do in the wider context. Go for it.
Yeah, so I mean, we're both former teachers, and it's very easy to think about sort of resource creation as the work of education designers, and as teachers, you're often creating in a rush on the fly with a very specific set of criteria and maybe imperfect restrictions around what you're doing, and everything tends to be a process of trying to make something fit what you need it in the shortest possible time in order to do the lesson and have some kind of meaningful success in that short space. I think educational design is being able to think about the same issues from a position of massive privilege, and that's essentially where we sit. But we get to think about the individual mathematical goals and mathematical techniques and ideas that we're trying to get across to students, or that teachers are trying to get across to students. Rather than doing it in a rush with all of those restrictions and things, we get to sit and pore through all the available research, research related to the specific things, research tangentially related to those things, think about the connections, think about what it means to actually understand a mathematical idea rather than simply to be able to enact some mathematical process that's related to that idea. And kind of the whole ecosystem and infrastructure around what goes into creating an episode of learning that a student might experience. So it feels like a much broader thing, but where we get to basically have fun reading other people's research and turning it into interesting, exciting things, and sharing it with people.
Yep, so a systems approach, one might say. Excellent, okie dokie. So to the topic of this talk, we picked pie charts just because we happened to be thinking about them a couple of months ago. And one of the things that we were thinking about is how hard pie charts are. And they're hard because there's so many important concepts involved in understanding them. So we tried to make a bit of a list of all of the concepts that we think may be part of an understanding, not a complete understanding, an understanding of pie charts. So Darren's going to talk you through those. Off you go.
Thanks. Yeah, I mean, it's one of the things that whenever we start and sit down and think about mathematical ideas, it always ends up as being a bit of a rabbit hole, and particularly with the ideas that as educators and as mathematicians who are confident at doing these things, it's very easy to kind of assume that they're relatively straightforward. But as soon as you start to sort of scratch under the surface, you start to see that actually the bit of the iceberg that's underneath the sea when it comes to any of these concepts is generally quite extensive and goes into all sorts of places where you don't necessarily expect they might be. So pie charts is quite a nice one because it's quite easy to get under the surface very quickly and come up with a fairly substantial list here, and this is by no means all of the elements. But there's a huge element of understanding which is related to geometry, obviously, the structure of a circle, understanding of angles, understanding of the relationship between parts of a circle that are not necessarily obviously the same, but are actually the same. So the angle, the area, and the arc length in any given sector essentially standing for the same proportion of the circle. And that's an incredibly sophisticated idea when you really think about it. And quite often we're teaching pie charts to 10-year-olds, 11-year-olds, and expecting them just to somehow accept that and understand it without really having to think about it in too much depth. And you go through, I'm not going to read through this whole list, but thinking about how data is transformed from one thing to another, from one form to another, is another really actually very deep conceptual thing. Like the idea that these things that can be numbers or lists or whatever can be turned into an area or a length or some blob of color on a screen is not, again, it's not a trivial thing to understand. It's like it's easy to take these things for granted, but actually when you really think about it, if you imagine a 10-year-old and 11-year-old accepting that without saying, well, why might that be the case? Actually, that's quite a big step. So yeah, I don't think I want to go into too much more detail with these. Were there any that you thought particularly stood out?
No, because we'll get to that. I think we'll get to all this juicy stuff when we show lots of lovely examples shortly. Yeah. So that's just to, as we say, give a bit of an overview of all the things that we found when we started digging under the surface. So pie charts are hard, but they are quite funny. And the internet's full of funny pie charts, which is perhaps one reason why maybe we should teach them. I don't know.
Because of the memes.
Because of the memes, right? I don't know. Darren made me do this because he said without the black background, people might not get it. He didn't make me do it. He invited me to do it as a co-collaborator. But they are quite funny. There's a lot of funny jokes. It's hard to get unless you know basic maths, and quite useful. And the utility of pie charts is something I come back to time and again because I love to design charts and graphs and diagrams and infographics, and I spend a lot of my time doing it. And I was saying to Darren while I was thinking about this presentation, they're not even really in my top 10 of useful diagrams. And the fact that we kind of concentrate on them so hard, we go hard on the pies at school level, sort of baffles me. And so this presentation was partly an attempt to think about why that might be and partly an attempt to question it. And so we've kind of tried to think very carefully about, is there a good reason for it? And if there isn't, then what could we do differently that might, change the focus, shift the focus a bit? So we're going to just have a little game now because we're designers, and when we're supposed to be writing a talk, we design games. That's what we do. So we thought it would be really fun just to explore pie charts through a small game. We have imaginatively titled Pie Logo. Darren, do you want to give the rules of Pie Logo?
I mean, I'm not sure we'd ever really assign the rules, but the game is very simple and straightforward. Very shortly, you are about to see something that could be considered a pie chart or a proto-pie at the very least. Which represents the logo of some kind of brand or company through the proportions of colours of the logos. And your task is to put in the chat or shout out if you think that you recognise or you can work out what that logo may be. And there will be, I don't know, 1 million points for a correct answer, let's say.
Wow. I mean, that escalated quickly. All right.
I mean, yeah.
This game is in beta. It's a proto game. So if we have suggestions as to how we can improve this game, we'll be happy to take them. Okay, here's the first one. So, shout out. What was that? Sorry.
Microsoft. Windows.
No, I tricked you.
I said that the first time.
It isn't.
Google.
I did it on purpose to trick you. What was that? Sorry.
Google.
No. Keep going. Anyone else got any thoughts? The proportions are very important.
Are we giving clues? Are you going to give a clue?
You can give a clue if you want.
I can't remember what it is.
Slack.
Not Slack.
There's a very business heavy set of responses here.
Chrome.
Nope. Anyone guessing things in the chat that I can't see, please throw them.
We've got Chrome, Google, Slack. Other search engines are available.
It is interesting when you look at logos this way, how many of them use a similar colour scheme.
Mm.
And that seems like a bad decision to me. This is actually.
I'm trying to think of any examples that aren't like symmetric. Somehow the proportions being off is like.
Right, and this was done very quickly by me, but this is actually eBay, and it's because of the letters used that the proportions come out like that.
Mm.
And it's actually really hard to estimate proportions of colours used on different letters. It was actually really interesting designing this. Okay, next one.
FedEx.
Yeah. Oh, I knew
wow.
best friends would get this one. That was it. That was an impressive amount of.
We've got Drew made that answer in the chat as well.
Excellent.
I don't know if
Good
that was
work,
Drew
everyone who
shouting
said
out,
that. Superb. Okay, this one.
Texas.
Was that the Texas flag that we got?
It was not. It's not the Texas flag. This one was
See, I
interesting.
guess Cuba, but
An airline, maybe?
What? That? Sorry.
The Union Jack.
Pepsi or an airline?
It
The
was
American
Pepsi. Good work saying Pepsi. And the interesting thing here was the choice of order in which I put the sectors actually made a really big difference. And it makes it much easier to see if I put them in a certain alignment. And I sort of didn't, just to make it slightly harder.
Right.
It was too easy. Okay, this one.
Okay, that one's Google.
It's not.
The Olympics?
Someone's
that?
really good at
very
that.
good at pie logo.
oh, Drew and Grant both called that.
Oh,
in the
good
chat.
work. Good work. Maybe we need to just slap a patent on this straight away. And this was very interesting again to design, because my first initial thought was all of these sectors need to be of equal proportion. And then I looked really closely and realised they didn't. Does anybody know why they're not?
The overlaps.
What was that, sorry?
The overlapping.
Yeah, so the two on the outside have slightly less overlap than the three in the middle, which took me a minute to think about when I was doing it. So anyway, so what is interesting to me is actually designing this game taught me more about pie charts than 10 years of teaching them. And I reflected on that while we thought about some of the themes in this talk. So we thought about our experiences of teaching pie charts, and this is in UK curricula. And I suspect people may recognise this model from teaching elsewhere, but please do let us know in the chat if you see big differences from elsewhere. I'm going to hand over to Darren to talk about what these may have looked like in his practice.
Yeah, so some of this is this kind of way of teaching and breaking it down into very specific skills, and then making sure those skills are established in some kind of progression, some sort of timeline. Not necessarily done in the kind of left to right order that appears on the screen, but certainly I think most teachers, certainly within the UK, and I would suspect internationally, would have some version of what we can see on the screen here. And some of that comes down to the way that this kind of thing is presented, in terms of as a sort of a learning objective, and a thing that can be broken down into components that tend to be tested in specific ways. So when I look at these kind of descriptions of the techniques that are involved, I can imagine assessment items where part A is doing one of these things and part B is doing another and part C is doing another, and that naturally then sort of leads into how the teaching and learning happens in the classroom. But I think it's a really interesting to contrast this to the activity that we just did. That when we were putting this presentation together, immediately started to think that actually that's a really nice way to focus in on some element of pie charts without having to worry about all of the extra technical details. Because what we did in that last activity is to focus on the relationship between proportions from the thing that was acting as the source, the data, if you like, and the representation as a pie chart. And there was no having to worry about calculations to get there. There was no having to worry about these individual data that's collected and the different types and that sort of thing. It was like, it's kind of the shortest step of transformation from data in one form as the logo to the data in another form as a pie chart, without having to make any change. We're not changing the form, we're not changing the colors, we're not doing a translation from numerical to area or length or whatever. It's literally just a kind of a transformation of the logo into a circular form, if you think about it like that. But it zeroes in on a really fundamental element of understanding of pie charts without having to do loads of maths teaching to get there. And so to go back to the kind of the thing that we were talking about as being educational designers before, the really interesting thing becomes, well, how can you curate these kind of experiences which allow you to develop those conceptual elements and then put it together into something that is a formal pie chart that can be reproduced in interesting and well, possibly not interesting ways in an assessment, but in a way that you can say the student has this skill and understands what's going on. But actually really zeroing in on the fact that proportional understanding is the key. It's not, can you draw things with a protractor? Can you name the different parts of the pie chart? Can you measure the angles and do all of that stuff properly? If you understand your reading proportion, then a lot of the misconceptions that come out of learning these individual skills and not getting them quite right kind of disappear, hopefully, is the kind of the plan, the thinking.
And
I just checked the Common Core state standards in math. Pie charts are not in there. Charts are not in there anywhere. But everything you're saying is in there in terms of like trigonometry, building up a rich understanding of the unit circle representation would do everything it needs.
Yeah, and I've made this argument a few times actually that if I was writing an assessment, if I'm designing assessment and I want that assessment to use if I want students to understand pie charts and use them in their sort of data work, their statistics work, I wouldn't design an assessment that focuses on creating them, drawing them, whatever. I might have someone, that they have to look at and some context and they're doing some comparison, that sort of thing. If I wanted students to draw a pie chart, I would consider that to be assessing the sketching out the angles or the actual, those other skills that are within pie charts, but are actually not that important to the statistical aspect of interpreting and understanding the data that's going on. So I would always make the argument, I do make the argument that if you're testing statistics, don't worry about all this drawing and construction stuff. But if you want to test the skills that are important for the drawing and construction, then fine, use a pie chart, but use that as a context for embedding those other skills rather than for the benefit of being able to do a pie chart.
Yeah. So the proposal we make is, instead of this model, which I've conceptualized here as a little whacker teddy, bam, angles, bam, drawing circles with a protractor. And believe me, it feels like that when you're teaching it. And it feels like as soon as you've taught them to do it, the next year, bam, you've got to hit it again because they've forgotten. Instead of that model, something a little more Lucy, a little more organic, dare I say, a little more rhizomatic and connected. And so what we're talking about is just instances of the same structure. And this structure is proportional reasoning, part-whole models. As Darren says, that's the thing. The pie chart is just an instance of it. And, we're using a circular model. It kind of doesn't matter. A waffle diagram does this too, and arguably does it more simply. And there's all kinds of other statistical diagrams that also do this kind of thing. The fetishization of the pie chart is very weird, but this is the kind of thinking that we do all day long, thinking about how can we make something explored as an instance of I guess an equivalence class, rather than just saying these things are discrete and let's teach them discretely and not connect them properly. And so I have taken the liberty of just popping in a little picture there of the sort of thing that we do. So we design these kind of maps of maths in our everyday work at Cambridge Maths. This is the kind of thinking that we do. So here's the proposal that we're putting. The way that we are conceptualizing this that we think is slightly more connected and interesting. So these are different instances of exactly the same kinds of thinking that you might do at different times with students. And they don't have to be done in this order. Thinking about making protopies. So attributes of circles. Why are we using circles? What's the really interesting thing about a circle that I might use in order to do a diagram that's got part-whole models in it? Generating circles and uses of circles for modelling proportion. So that's really important to this thinking, and quite often it completely bypasses all of this reasoning because kids don't connect the circle stuff to the pie chart stuff. They just learn how to draw it. Making and transforming pies we're going to talk about. So I constantly talk about playing with boundaries, as Brian will know from hearing me talk about being queer in maths and all sorts of other things. So I'm obsessed with it. But why not play with the boundaries of everything? So if this is a pie chart and this isn't, why? if this is nearly a pie chart, what makes it nearly a pie chart? All of those questions are really, really important and fundamental. And thinking about, what makes a graph a good graph is also a really important question that kids should be asking almost at every age, really, when they're using data. And then designing their own, but critiquing other people's too. And I have put there, because I think this is kind of my statistical mantra: just because you can doesn't mean you should. I love to draw pictures, and I will draw pictures of almost everything, but that doesn't mean they're always useful or applicable to everything. And I think we all know, because we have all seen them, that drawing a pie chart of data doesn't mean it's a good way to display that data, as we shall see. And then my last part there about, because a pie chart or any kind of graph or chart really is about storytelling, it's about communication. What does it mean to tell the truth of the pie chart? This is something I've been thinking about for a long time. I think we can identify opportunities people have taken to not tell the truth, but how do we know we've told the truth with data? That's something that I come back to time and time again. Okay, so let's think about this sort of proto-pies idea. What's the kind of activity we could do with children, who might not be at the stage yet where they have all of these attributes, all of these elements clear in their mind? They're not ready for pie charts completely, but what sort of thing could they do that would help them to prepare for those, all of those elements to come together in a useful way? So I've been making some proto-pies. I've been thinking about what kind of thing could we make that looks a bit like a pie chart, but probably isn't, and what kind of thing might it tell us about what we're looking at? So Darren, do you want to talk about this a bit? I was about to say, I know you like screws. Deary me. You're on mute.
Excellent. Technical proficiency. There are some elements of this arrangement that I find really interesting, because to some extent this is a sorting activity that has developed into something that then looks reminiscent of a pie chart and obeys some of the rules of a pie chart. But what I think is really nice about this, and some of the other examples you're going to see fairly soon, is that it really blurs the boundary between what could be considered discrete data, the count of how many of each type of screw there are available, and the representation of proportion on a pie chart, which is, in some sense continuous. And that's quite interesting, and again, quite an invisible thing, but quite a complicated concept for students to take on board. It kind of isolates here the idea that within a pie, even though it becomes invisible, a set angle is allocated to each individual counted data point, essentially. But in this version of the diagram, you can see that it's there on the screen, and it's there to kind of pick apart and talk about and explore, which makes it a very different thing from having the pie chart and the table that has a count of brass screws and black colored screws, and then a pie chart next to it showing it. There's this extra stage of that translation that's visible within this fairly informal diagram, which again doesn't take any particular maths skill to be able to come up with.
Oi.
It's a very pretty arrangement of screws. Well done.
I looked very carefully to find some screws to make this. It's kind of like an exoskeleton of a pie in some sense, isn't it? Interesting. And then this one, because what you can't see here maybe very well is that those screws aren't all the same length, which made me think, oh, maybe I need to emphasize that more. So then this one, where that's much clearer. And this is, much more obvious that it's not pie-like, I guess. It's not circular. We don't have a common radius happening here, but we do have something interesting happening. And again, as Darren says, it's a kind of sorting, a kind of organising happening, something about a common angle, which you can still see, even though the lengths are different. And then something about a kind of diagram coming out of here, which is not a pie chart, but something else, right? You're seeing a spiral maybe happening, a Florence Nightingale type diagram. Yeah. So this was a really interesting activity. So I'm going to pause here and see if anyone does know what they think I'm maybe about to do here, or indeed I did.
Yes,
And the graves on the side.
Painting something in the chat.
Yes.
Right, the person who said painting something gets 2 million points.
So we got spirograph. I was kind of imagining with that
Self-portrait.
dot that you might be spinning something.
Love it. Excellent. Okay. Did you say spirograph?
Mm-hmm.
I mean, that's intriguing, given that I've got paint. So what I did was I kind of came at this from the opposite angle. It was really interesting. I had some paint and I had a paper plate and I thought, how can I make a pie chart and what does that pie chart show? So I smeared the paint and it didn't smear very well, which was very annoying. And I made this and I thought, I've definitely seen something like this before. I think my children came home with something like this from nursery. It wasn't, great. And I'm sure I've said well done. And I thought, what is this? Is this a diagram? Does this show me anything? What does it show? So I tried to write a title for it. So I've written the title and this says at the bottom, what colours are my paints? And the first thing I thought there is, I hate that title because it's not great. It shows me the colours of paints that I have, but in terms of proportion, it doesn't show mathematically the proportion of paint colours that I have in any kind of reasonable replication of what exists outside of the chart, right? So it's an object graph, but it's not a good one. So that was something that bothered me. Mathematically, this is not doing any work, and it's certainly not doing any useful work. So I tried retitling it to see if I could make it do any useful work. So it now says, how far have I smeared my paints? And this was a really interesting exercise because, again, I'm assembling a pie chart out of physical things in front of me. I've got some paint. I've got this idea of proportion. I've got something circular. I want it to do some work. I'm not really sure what kind of work I want it to do. As an artist, it's actually very useful for me to have, for example, some kind of dried paint picture so I can see what colours my paint are when they dry. Do I care about what proportions they are? Maybe. It's quite useful to know what I have left. But actually, this is a fairly useless pie chart. It's completely pointless mathematically. And so, I'm starting to get underneath this idea that not all pie charts do interesting, useful mathematical work. And that Protopie is telling me some information there about, in the kind of set of all pie charts that I can make, only really a small fraction of them are interesting and useful. I think that was what I got from that. I don't know, Darren, do you want to add anything?
Yeah, I think there were two things that come out of this that I think are really interesting. One which is quite mathematical, and the other one which is more about barriers to student learning. So the mathematical one is just I was thinking about this idea of the paint representation of how much of the different paints I have. And actually that's incredibly, if you really think about how to achieve that, that's quite difficult because if I've got more paint, then I'll squeeze more paint out onto my diagram, which means I'm going to have less paint left over of that colour than I had. And they're all changing in relation to each other if I'm trying to do all the colours. So actually the mathematics of modelling that is not trivial if you try to do that in a kind of, if you did try to really get into the guts of the maths of that and actually model it and make what you end up with be an accurate representation of the amount of paint that you had left having made the diagram. That sort of sparked the maths part of my brain more than the education part of my brain. But then the other thing that I think is really important that comes out of this from the student experience point of view is this idea that actually what happens for young children an awful lot of the time is they see lots of things that look very similar, sometimes within mathematics itself, sometimes between different subjects. So they might see something that looks a bit like a pie chart in an art lesson, which is actually some kind of color wheel and is there to represent the different colors they have available or the kind of, this is not my area, color wheels and things like that.
You're right, those things definitely exist.
But for a young child, there's no reason to assume those things are different or obey different rules unless they're explicitly told. And how do they go about inferring just when they see the thing at first glance? Oh, well, this one's a mathematical thing and this one is doing something different in context of a different subject. And actually, we get that an awful lot in maths. So one of the other things that I've been writing on recently is about symbol sense within mathematics and thinking about how students think about algebra. And one of the major issues being that actually, when you see an X or a Y or an A or a B or whatever, like it can stand for an actual unknown, it can stand for a specific value that is unknown. It can also stand for a true variable that's allowed to change and define some kind of relationship. And if you're just seeing some X and Y's on a page as a student, there's no reason to assume or to know instinctively what that letter is actually doing. There's 4 or 5 different things within their immediate experience that it could be doing, and knowing what to do next depends on knowing, well, what is this thing that I can see? And that issue crops up in mathematics all the time, and I think is quite nicely highlighted by this diagram of like, why should a student know what this means? Ultimately, the question that you have to ask yourself as an educator is, how do they make that distinction? What structures around it do I have to situate and make them look for to be able to say, oh, this is one of the things that I know does this particular function and follows these kind of rules.
Right.
And sometimes that's easier and sometimes it's not.
And that comes back to what you were saying with Pi Logo, where we've got these increasing levels of abstraction, starting with really quite, a short pathway from the thing that we're representing all the way through to increasing levels of taking the data and really transforming it and having to really kind of manipulate it quite a lot to make it into this proportional area circular type diagram. And quite often we're doing that in such a kind of formulaic, chew it up and spit it out way with kids. They never get to do it in those flexible, interesting design type ways like this, and really asking from a different point of view, hang on a minute, I've got this situation. Can I draw a pie with it? Which is what I did. And it was really hard. It was really interesting to think about it from that point of view. Yeah, so this is something that I thought about too. So again, from an art standpoint, I had these coloured pens. I arranged them in a circle, thinking about, again, maybe this is a proto-pie, maybe it isn't. At the moment, they're discrete. And I arranged them in a kind of rough colour wheel order. And then I thought, well, what's the next step here? So drawing coloured dots. You'll see this is very sketchy because I was excited. I went fast. So I drew the coloured dots out on the circular paper plate. So thinking about, am I stepping towards a pie chart or away from a pie chart here? In which direction am I going if pie charts are over there? Then, okay, maybe I can draw some lines. Darren has something to say about this, I think.
Well, just to see if anyone can spot your deliberate mistake.
It wasn't deliberate. As I say, I was excited.
The orange one that is with the reds.
Yeah.
Yeah. One of the things that, again, when you sort of doing these tasks and thinking about, well, okay, what can I see on this and what stands out? And this one I found very interesting from the perspective of thinking about drawing histograms of discrete data, which again is something that was on the curriculum in the UK. I think it's less so these days. But this idea of kind of turning a discrete value into something continuous by using the midpoint, which can be really difficult to explain to students as to how and why you would do that. But actually in this diagram, it kind of happens automatically because you have to work out, okay, where, if you're going to make these sectors and you're going to draw that line in, you have to find the point that you're going to draw that line to. And there's an interesting discussion. So, well, do you put it in the middle between 2 points? Do you put it on the last one of one section and the first one of the other? What's the implications of that and that kind of thing? So there's some quite complicated thinking you can do with that kind of discrete continuous borderline with this very simple diagram that can actually make something that by the time we tend to teach this stuff, we've moved to the point where we're just talking about things in a completely mathematical context, and we maybe don't go back to something as simple in some sense as this and explore the idea and the concept first before putting it into that mathematical numerical context.
Yeah. So the obvious next step is to colour, and I corrected my mistake, as you'll see. And some interesting stuff here, because again, you can still see shades of different colours within the sectors, looking more like a pie. And now I've cut it and labelled it. And I'm interested in my decision to cut it. I wanted to. It felt nice to cut it into pieces. So we've talked here about kind of making what we call proto-pies. And then we've also talked about this idea of kind of breaking and transforming. And this is something that bugged me. What happens if I took those same slices that were arranged circularly and just put them in order of size? Assuming that the first thing were a pie chart by anyone's definition, is this still a pie chart now? You know, what is it that has broken that rule or transformed that in some way? Or indeed, if we organise them in a kind of nested way, what might have changed, what might be easier to see, what might be harder to see. That was really interesting for me to think about as well. And when they're physical like that, it's quite nice because you can really move them around and manipulate them. So it's just some things to consider there.
And also, again, just on that last one, the common misconception or mistake that students make, or certainly students that I taught made, when they were first getting used to drawing pie charts is starting from, like, when they're measuring the angles to draw the sectors of the pie, measuring from, you know, effectively due north for each individual section. So actually what happens is all of their sectors overlap each other, and then they have a whole load of the circle that's not used. And an activity like this, again, is an opportunity to highlight, well, why might that be the wrong way to do things? Why do you need to spread things out around the whole circle, and what do you lose by having them overlapped like this? What information can you not see?
It's nice. So we realised we've been doing some very loosey heavy activities, bits of paper plates and stuff. Thought we'd show you some actual theory. Darren's going to talk about this.
Yeah, so there are, I mean, various things that come out of research around data displays over the last, I guess, 50 odd years or so, kind of Tukey, Tuft and those kind of folks. But trying to boil it down to when you have a chart, a graph, any graph, not just the pie charts that we've been talking about so far, what actually are the bits that are important of those? And again, thinking back to how we traditionally teach things, we tend to teach that, okay, so we're going to look at a bar chart today, and this is how a bar chart works, and these are the rules. And then we're going to look at a pie chart, and this is how a pie chart works, and these are the rules, and we can do the same with a scatter diagram and all sorts of other things. But actually, when we're doing that, we tend to focus on very fine details. But every single chart has these kind of similar structural elements. So the framework of the graph itself, the axes potentially, or the table boundaries or whatever, it's got specific visual elements that are used to represent the data. So in the case of the pie charts, the angle, the sector that's coloured in. Often labels, although not always, and often some kind of grid underneath, although again, not always. If you think about the pie chart, there is an implied grid there, but it's never, you don't tend to draw all 360 degrees as individual sections and then put your lines in place. And so all charts share these characteristics, and when we're interpreting charts and looking at charts, and when students are interpreting charts and looking at charts, there's a lot of value in getting them to look at these different components and think about what they're doing in each individual case, because sometimes they'll be really crucial, and sometimes they'll be distracting, or sometimes they'll provide extra context. So the background is a really interesting one, but quite often the background will be non-mathematical. It will be designed to add some context somehow. And that can be true of visual elements as well, if you think about pictograms and things like that, or perhaps the colors that you choose, as with the pie logo. The visual element is actually really important there, because the decisions that you take are crucial of having a one-to-one map between the color schemes. And so starting to turn the thinking process when you're thinking about designing educational activities around graphs from what are the rules of this one I'm looking at, to what are the elements and what are the graphical signifiers. So what is it that communicates frequency on this? Is it length? Is it angle? Is it area? Is it color? If we're thinking about the kind of colored maps to communicate values of quantities in different places. What are those graphical signifiers for a specific graph? and what other graphs share those things as well. And the way that I tend to think about it, I was talking about this to Lucy, is if you imagine there's kind of a continuum, some kind of spectrum, where you could represent every single possible type of data representation on it. What we tend to do in education is we sort of fetishize a handful of specific examples of data representation, and we teach the rules of those. But that only ever is going to give you access to a very small proportion of those. And when you think about the design of infographics and the visibility of data and how data is represented in the modern world, in the media and so on, very few of the charts that are actually displayed tend to follow the same rules as the rules that are taught at school, sometimes deliberately in order to confuse and to misrepresent, and sometimes just through design decisions, making it pretty being more important than clear communication and everything else in between. So really focusing on these characteristics and the actual signifiers, what's going on, the structural elements is really important in this kind of work.
I do agree with you. I was making that face because I wanted to be clear that making things pretty and communicating things clearly are not mutually exclusive, and of course one can do both.
Absolutely.
No, but you weren't necessarily saying that very clearly. I would like to pause there and take some questions because I think it's really important that we do. I would love to invite people to talk to us, grill us, ask us things, challenge us. Go for it.
So the first thought I had was that maybe the reason pie charts get a lot of attention is that area and something one-dimensional, like the angle kind of length, align with each other in a pie chart in a way they don't in other two-dimensional representations, where you have to be concerned about, is that rectangle, is it just the width, or is it the area of that rectangle? But in a pie chart, they're the same.
Well, if it's not a 3D pie chart,
yes, of course,
she says, rolling her eyes, which is most of the ones used in most magazines and newspapers you tend to come across. Sure, yeah. Darren, do you want to speak to that?
Yeah, I mean, I have my own pet theory about why pie charts are so ubiquitous, and I firmly blame Excel and the fact that essentially, like, that if you look at most spreadsheets, and Excel being the one that most people most widely used, it's incredibly easy to create pie charts in Excel, and it's incredibly difficult to create most other types of charts that might be more useful or in Excel. And so my pet theory is that part of the reason why they're so familiar to people and why it seems so important that we keep teaching them is because actually they appear everywhere because they're easy to make, not necessarily because they're the best diagram in any given circumstance. And then that becomes a self-repeating thing because you see a report, you feel like you should bang a pie chart in it. And I've certainly worked with lots of people that use a pie chart as a punctuation almost within a report or a series of reports because you can.
Yeah.
There's two things that just come straight out of that graph characteristics picture to me. And one is the shading. And for some people, shading is actually difficult to discern. It's almost as bad as color blindness. I have books behind me, and I sent a critique to the author, and I got back, you need to change the lights you've got, because the thing wasn't, well, it was a fair comment, because the lighting I have above my head is not good. But it's also a fair comment from me to say, hi, Prof, your book says X, Y, and Z. I can only discern two colors, so I can only see X or Z. I don't see this white space that you're talking about. So we had a little chat. He's going to make them more defined next time round. But for me, I can't tell you exactly what frequencies I'm vulnerable to, but I can say to you that basically the bottom line on the right-hand graph with the yellow background has, as far as I can see, 3, possibly 4 tiny. There's probably, but it's a thing to consider that, in representing information to people, to actually make it really discernible. And when you're dealing with pie charts, does it match the function? You know, are we talking about percentage, or are we talking about it doesn't really have a function of 5 people out of 10 in my mind, or 5 people out of 15. That doesn't relate. That kind of visual thing doesn't work. That's better with a histogram. And that choice is just a thing that maybe, I don't know if you wanted to add that into where you're going.
Yeah, I think what Darren was saying there is even just saying a pie chart or a histogram is problematic, because those are so not the only options, and they're not. Those are just instances of the kind of chart that is possible. That there are an infinite number of the types of charts that anyone could design. They don't yet have names, some of them. Darren and I, probably between us, have invented new types of chart, I think, in the last couple of years when we've been designing infographics, because we have thought about these types of characteristics and said, all right, we've got some data, we want to show this, here's the type of job it needs to do, and here's the way that we could show this, and here's the dimensions we have, and all, that's the type of situation we're dealing with. And you're absolutely right that the form should fit the function, and that's just good design. But equally, you don't have to snap to the grid of what formula has done before and what you've been taught at school once you understand the rules that you're working with all design. You absolutely can say, okay, yeah, I want to use area to represent proportion, and actually I don't need to use a circle here. I can use a donut shape, that's fine, because there's a good reason for it. We go through this process quite a lot in design. We say, is it reasonable? Is it justifiable mathematically to do that? And if it is, it's okay in our opinion. It's not this kind of absolute blind panic of I've done the wrong chart. I did a wrong. I don't know. Do you want to say anything about that, Darren?
Yeah, I think this is, again, in one of the arguments that we make a lot around when we're thinking about curriculum design and the kind of task designers is actually one thing that doesn't get done a lot in schools, partly because of this focus on, like, today we're learning about pie charts. And so here's a bunch of data and we're going to use that data to make pie charts. And the data is pre-selected to produce pie charts from which you can answer a fairly contained set of questions from that make sense and so on. That actually what isn't done often is say, well, here's some data, make lots of different charts types of charts using the same data, and decide which of those is the most appropriate and the most interesting. And the obvious thing that stands out with the sort of pie chart stuff is that it works really well if you're trying, if you've got some fairly substantial differences between the quantities or the proportions. If they're all roughly the same, or if there's loads and loads of different categories that you're trying to represent.
Should we show a bad?
And it's a terrible diagram.
Do you want to see a bad?
Yes.
That's good.
Oh,
that one.
Oh, lovely.
Yeah. and again, going back to that ease of creation thing, well, yeah, I'm sure we've all seen examples of this kind of pie chart published in decent journals and magazines and sources and things that clearly someone's pressed a button, said, give me a pie chart, it's given them a pie chart, and that's enough for it to go into the document, right? But there's got to be a better way to represent this data. And I think someone mentioned in the chat earlier, it's that real focus on the idea of actually selecting the best representation of the data. And that's not necessarily a single correct answer, because actually the best representation has to be related to the question you're trying to answer with it.
And the audience.
And the audience.
Because it's communication, right?
Yeah, and then you also get those decisions, as you say, about, well, okay, so also building in the accessibility of this.
And your humour, right? Hence things like this, which I like. I was just saying to Darren when we chose this, is this an example of good design or bad design? It just depends. This is, if a child designed this after a lesson on pie charts, I wouldn't be mad at it. I think they'd understood pie charts because there is a really good understanding underneath that, even though, that isn't a correct use of pie charts. It's just really interesting. Sorry, I interrupted you.
But I think also this one's a really interesting deconstruction of the elements we talked about before. Like, well, the pie chart's really interesting because the angle, the area, and the arc length all represent the same value. And actually what's happened in this one is that symmetry between those three things has been broken by this arrangement. So now you have to ask a different question about, is it angle, is it arc length, is it area that's actually being used to represent the proportion here? Because it's not all three doing the same thing anymore. And that's interesting from a structural point of view.
Yeah.
And looking at these broken things is a good way, as we sort of alluded to earlier, of understanding what the correct rules are.
Yeah, who needs correct? No fun.
Well, we need to wrap up in just a minute. Any other last question before we do our conclusion?
I've just noticed someone has put in the chat audible gasp, and I'm intrigued to know what that was.
What did we do?
It was about the terrible pie chart.
Right, okay.
Of the emojis. We don't have time to answer this one, but I was amused that you talked about snap to grid, suggesting that the space of all charts is a vector space, and you have a lattice in mind. And so I was kind of wondering if you had a spanning set of charts, maybe pedagogically, like these are the 5 things children learn about charts, and these 2 or 3 charts are enough to do them. But alas, I'll have to ask you about that some other time.
Sure.
I'm gonna steal the screen share for our little announcement. So next week is our last talk of this semester. It's with Steph Reyes. She's going to be, her title is I Do Math. This will be one of those mathematical journey talks about her experiences with math. And so I hope you all come back next week and join us. And please join me in thanking Lucy and Darren for today's wonderful discussion of not pie charts.
By 2 not doctors.
Yes.
Thank you so much.
Well,
2 nearly doctors, 2 proto-doctors.
I made that joke back at the start in the chat.
Oh, sorry.
Recall is great.